Now, we can look at uniform motion problems using the rational equations. Right? So let's take a look at a review on what is the formulas. We know that the distance is equal to rate times the times. And from here, I can manipulate it by this way. If I want to find out my time, then I can divide both sides by the rate, which is I got my time. So the time will be distance divided by the rate. Or similarly, if I want to find out the rate, I can divide the distance by time to get my rate. So these are the ideas that we're gonna use to find out the rate and the time, okay, if we know the other two cases. So first example, Lin can ride his bike 20 miles into a 3 miles per hour headwinds. In the same amount of times, he can ride 30 miles with a 3 miles per hour tailwinds. What is Link's biking speed? So in this case, what we don't know is what is his biking speed is. So my first step will be uh, that biking speed be equal to x. And remember, we want to use the chart, right, to organize our informations. So rate times the time is equal to distance. It's very important that you write down your formula so that it clearly tells me what you are doing in each column. And also you can keep track of yourself. And we have two scenarios, headwind and tailwind. If you're going headwind, that means the wind is slowing you down. So therefore, your rate will become slowing down. It's basically how fast you are biking, and then it will be slowed down by the speed of the wind, so it'll be -3. And similarly, the tailwinds is how fast you are going, but since you are a tailwind, meaning the wind is pushing you, so it'll go faster, so it'll be how fast you are going plus the speed of the wind. Now we got the rates already, and we want to find out the time. Now, it tells you that the amount of times that they travel using the headwind and the tailwinds is the same, okay? The same amount of time. So that means the time that goes by headwinds and the times that go by tailwinds are equal. But we cannot use another variable because we are talking about one variable equations. So we need to find a way to manipulate. We know that going with the headwind is 20 miles, going with the tailwind is 30 miles. And from what we saw earlier, right here, right? If you know the distance and the rate, you can divide the distance by the rate to get your time. So therefore, for this situations, my distance divided by the rate will become the time for the headwind. Similarly, the distance divided by the rate that gives me the time for the tailwind. And right here, it already tells you that they have the same amount of time. That means it helped me to set it up my second step. The time that goes headwind must be equal to the time that's go by tailwind. Now we can solve these equations. Since this is a proportion type, I can basically cross multiply method. So it will be 20 times x plus 3, that is equal to 30 times x minus 3. Distributing it, that will be 20x plus 60 is equal to 30x minus 90. Subtracting 20x on both sides, it will be 10x minus 90. And adding 90 on both sides, that will become 150 is equal to 10x. And divided by both sides by 10, that will become 15. And this tells us what is our biking speeds. So now I can interpret it. Biking speed is 15 miles per hour. Now, moving to the next example. Dennis went cross-country skiing for 6 hours on Saturday. He skied 20 miles uphill and then 20 miles back downhill, returning to his starting point. His uphill speed was 5 miles per hour slower than his downhill speed. What was Dennis' speed going uphill and his speed going downhill? So in this case, you never talk about, he's going against the wind or, going with the winds, anything like that. So right away, we can start with our chart. And it clearly tells you this is uniform motion problem. So my formula should be rate time the time is equal to distance. And we have two scenarios, going uphill and going downhill. The uphill is 20 miles and downhill is also 20 miles, the same distance. But what we know is when he go uphill, the speed is 5 miles slower than the downhill. So my downhill speed must be x and uphill speed is x minus 5. We know that in this case, okay, the total time is 6 hours. In previous example, put this so that way you can keep track of it. The time is what? The same, meaning they are equal. So, like in previous example, if I want the time, that will be the distance divided by the rate. The distance divided by the rate. And this time, we know that going uphill and then coming back downhill a total of 6 hours. So going uphill, the time, plus going downhill, the time, that must be equal to 6 hours. That is coming from right here. Skiing for 6 hours in total on that day. Now, we clear the fractions because this is not a proportion type, so I have to multiply by the LCD on the left hand side and LCD to the right hand side to clear the fractions. So 20 over x minus 5 plus 20 over x equal to 6. Distributing on the left hand side, when I distribute it to the first fractions, x minus 5 cancels it out, so it will become 20x. And distributed to the second fractions, this will x and x cancels out, so it will become plus 20 times x minus 5. Equal to, when I distributed 6x into the binomial, it will be 6x squared minus 6 times 5 is 30x. Simplifying a little bit further, it will be 20x plus 20x minus 100 equal to 6x squared minus 30x. Combining like terms on the left. Because of we are solving for quadratic equations, now I'm going to move everything to one side, which is on the right side. Subtract 40x on both sides, that become minus 70x. Add 100 on both sides, it will become plus 100. Now, we try to factor this. right? Solve by factoring. That's always our first step. Again, as usual, if you can simplify it, that way the number will be smaller and easier to continue. Notice that in this everything 670 and then 100, all of them are divisible by 2. So that means I have a greatest common factor 2. So it will become 3x squared minus 35x plus 50. Now the number is smaller, it's much easier to do the factoring. Okay? So I have 3x and x, and we want 35. So how can I get 35? So you can pause it for a second and then try to figure out the fact. So hopefully you got the factors already. Let's check. 3 times 50 is 150, and then we want what? 35. So 150 is basically, you can think about as what? Negative 5 times negative 30, right? Because 5 times 30 is 150, and then when you add it up, it will be 35. And remember, you need to divide it by 3, so when you reduce it, it will be 1 and 10. So my factor will be 3x minus 5, that's one factor, and then x minus 10, that's another factor. So hopefully you got that correctly. Okay. So now I'm continuing this. It will become, using the zero factor property, 3x minus 5 is equal to 0, and then x minus 10 is equal to 0, and I got x is equal to 10, and then solving the other one, 3x is equal to 5, and then x is equal to 5 divided by 3. So we have two situations right here, but however, one of them cannot happen, because 5 over 3 minus 5, that is a negative number. So we know that the speed cannot be a negative speed, so therefore this is not a good answer. So finally, I can ignore this part and then do the interpretations. So my step 4, now I can say that his downhill speed is 10 miles per hour and uphill speed is 5 miles less, so it will be 5 miles per hour. So that would be my final answer. Moving on to the next example. Kayla rode her bike 75 miles home from college one weekend and then rode the bus back to college. So two scenarios, one time ride the bike, one times the bus. It took her 2 hours less to ride back to college on the bus than take her to ride home on her bike. And the average speed of the bus was 10 miles per hour faster than biking speed. So now we are interested in finding the biking speed. So moving on this one. My first step, again, this is rate times the time is equal to the distance. And we have biking and then going with the bus to the scenario. Right? Now, it said that 75 miles from home to college, so biking and bus is the same distance, 75 miles. And in this case, we know that the bus is 10 miles per hour faster than how fast she can bike, so it will be biking will be x and the bus will be x plus 10. From here, we can find out the speed, the time for each case, which is 75 divided by x and then 75 divided by x plus 10. Now, to set it up the equation part, this is where it's telling you, okay? It took her 2 hours less by the bus, okay? Took 2 hours less by the bus. So now what we have is we have the time that take bus and then the time by biking. Since the bus, by going bus, it will be 2 hours less. In order to make the times and then the times of taking bus and the times of taking biking equal, I need to add 2 hours to the bus. Think about this. You have to make sure you get through this correctly, right? Because always this is the mistake on the test, usually what I found out. So taking the bus, it is 75 over x plus 10, and the times for biking will be 75. And since the times of biking is longer, and then we need to add 2 to the bus to make it equal. So now we're going to solve by multiplying both sides by the LCD, which is x and then x plus 10 to the left hand side, and then x plus 10 to the right hand side. 75 over x plus 10 plus 2 equal to 75 over x. So distributing to the first term, x plus 10 cancels it out, so it will become 75x. Plus distributing to the second one, that will be 2 times x plus 10 equal to, when I multiply on the right hand side, x and x cancel, so it will be 75 times x plus 10. Now, continue solving this. This will be 75x plus distributing 2x, it will become 2x squared plus 20x equal to 75x plus 750. Quadratic equation, so I'm going to move everything to one side. 2x squared plus 20x, because 75x, when I subtract it, both of them is gone. And subtracting 750, it will become minus 750 equal to 0. 2 is the greatest common factor, so we factor 2 out. That becomes x squared plus 10x minus 750 divided by 2. That gives me 375 equal to 0. Now, again, pause this and try to, factor it. See you can you can factor faster this time or not. So 375, that is basically 25 times 15, and 15 minus 25 give me 10. So this gives us x minus 15 is equal to 0, and x plus 25 is equal to 0, and I got x is equal to negative 25, and x is equal to 15. And we know that we are looking for the speed, so the negative cannot be our rate. So now I can answer my questions, which is, can a bike speed? Okay? That is x. So therefore, we can say that the interpretation, biking speed is 15 miles per hour. And that would be our final answer.